Hi, this is Maggie. In this video, we're going to write a program that obtains a value from the user, stores it, and performs a calculation on it. Programs are a lot more interesting, general, and useful if they can work with values that are obtained from some source that is outside of the program, such as the user, a file, a database, or some hardware like a sensor. I'm going to write a program that will calculate the angle between stars evenly spaced around a circle, as in these two pictures. In the picture on the left, there are 8 stars distributed 45 degrees apart around the circle. In the picture on the right, there are 12 stars distributed 30 degrees apart around the circle. If we ask the user for the number of stars, we can calculate the degrees between stars by dividing the number of stars into 360, the number of degrees in a circle. In this problem, we don't know how many stars there are going to be until the user enters a value. We must store the value the user gives us in a variable so we can perform the calculation. So we can't write, for example, 360 divided by 8, or 360 divided by 12, but we can write 360 divided by num stars, where num stars is the name of the variable that references the value entered by the user. What do we know about the value? We know that it will be a number, and more specifically, we know that it will be an integer because we are asking for a countable quantity, the number of stars around the circle. It doesn't make sense for there to be fractions of stars. However, the result of our calculation, the number of degrees, is not necessarily an integer. Our calculations for 8 and 12 stars resulted in whole numbers because 8 and 12 divide evenly into 360. But if the user entered a value that doesn't divide evenly into 360, such as 11, then we would get a number with a fractional or decimal part. In programming, we call that a floating point number, or in Python, a float. Let's write our program. We will begin by writing a docstring at the top. I will write 3 quotes, followed by a sentence describing the program, calculate the angle between stars in an aerial firework, as that is the context that I'm imagining. Eventually we'll use a pygame window to draw some fireworks. The next thing I'm going to do is annotate the variables that I plan to use. I will write a comment that I am annotating variables. Remember that a Python comment begins with a # space annotate variables. I need a variable to hold the value that the user enters, and I think num stars is a good descriptive name for that variable. After we write the program, I'll go over the rules and conventions for naming variables. To annotate that variable, I write the name of the variable, colon, space, and then the type of the variable. We expect this to be an integer, which in Python is int. Notice that int turns purple because it is a data type. On the next line, I'll annotate the result of our calculation, which I will call angle. I will write angle, colon, space, and then float, as that could have a fractional or decimal part. Now, Python programs execute by default, top to bottom. We have written nothing executable yet. If you think about the calculation we want Python to do for us, dividing the value entered by the user into 360, then we must first obtain that value from the user before asking Python to divide. So our first task will be to obtain the number of stars from the user. I will write a comment, #, obtain the number of stars from the user. Now I will write the code to do that. This code will have 3 parts. I will type it first and then explain the parts. So on the next line I type num stars equals int open paren input open paren open quote how many stars close quote close paren close paren. This is an assignment statement, an input statement, and a typecast. On the left of the equals sign, we have the variable num stars. Remember, this is going to be an integer variable holding the value entered by the user. The equals sign is an assignment statement. It doesn't mean equality as in mathematics. It means that whatever the expression on the right evaluates to will be stored in or referenced by the variable on the left. So num stars is getting the value on the right. So what's going on over on the right? We read this inside out. So inside we have the input statement. It is the keyword input, followed by parentheses, and inside the parentheses, a prompt. The prompt is text that we're using to communicate with the user, and so it's enclosed in quotes. We call that a string, by the way. This means that the prompt, how many stars, will appear in the console and a cursor will blink until the user presses something. Hopefully the user types a number and presses enter. That is most of what's on the right. Now, whatever the user types actually gets returned to the program as a string or text. We don't want a text version of a number because we can't do math with that. So we are casting that text to an integer by enclosing the whole input statement in parentheses with the int function in front of it. As long as the user types in something that can be turned into an integer, this whole expression will evaluate to an integer. And that integer will be stored in num stars. Let's throw a print open paren num stars close paren after this statement and save and run the program. The print statement will print whatever is stored in num stars. So we can see that whatever we type will get stored in that num stars variable and printed back to us. I will save this as calculate degrees. And run it by choosing Run Module from the Run menu, and you can see that I am prompted to enter a value. I will type 12 and press enter. And it prints 12 back to me. Let me run it again. This time I'm going to just press F5 to save time. And this time I'll type 100. It prints it back to me. Now our program will crash or throw an exception if the user doesn't type something that can be cast to an integer. Let me run it one more time and show you this limitation. I'll type hello. And you can see that I get an exception. That's okay. There are ways to handle that. But to keep our program simple, we won't be worrying about that here. We will make an assumption that the user will type the correct type of value at the prompt. That's not a realistic assumption for real-world software, but it is an assumption we will generally make in these videos so we can focus on the topic we're learning and not a lot of input validation code. So going back to the program, I'm going to remove that print statement and move on to the calculation. I'll write a comment, #, calculate the angle between the stars, And then on the next line, I'll write the statement angle equals 360 divided by, that's a / on your keyboard, num stars. This is an assignment statement, as before, but the expression on the right side of the assignment statement is a calculation, not an input statement. Python will calculate 360 divided by whatever num stars references, and that result will be stored in angle. Let's finish this off with a nice message to the user telling them the angle. We'll use a print statement, but we'll make the output a little more user-friendly by writing a complete sentence. So first a comment, #, tell the user the angle between the stars. And then on the next line, print, open paren, close paren. Between the parentheses, I'm going to construct some output. Let me write some example output first. Suppose they entered 12. Then our output might look like, you will need an angle of 30 degrees between 12 stars. But of course, the user might not have typed in 12, and the angle isn't 30 if they didn't type in 12, so we need to substitute the values that are in our variables. Where there's 30, we need to substitute in the angle that we calculated. And where there's 12, we need to substitute the number of stars the user entered. We do this by enclosing exactly the part of the string that isn't our variable, in quotes, including any spaces, and using plus signs to concatenate in the values in our variables. Instead of 12 and 30, we'll put our variables there. I end up with, quote, you will need an angle of space, quote, plus angle plus, quote, space, degrees, between, space, quote. Here I'm going to press return so the line isn't too long, plus num stars plus, quote, space, stars, period, quote. You see how it's the same phrase, but I've made windows in it for our variables by closing up the parts that we want to literally say in quotes and using the concatenation operator plus to add in our variables. Now there's one other thing we need to do, and that's cast our numeric variable values back to strings. I do that by enclosing each one in parentheses and writing str before them. The str turned purple because it's a data type, just like int was above in the input statement. Now let's save and run this. And see how it works. This time I'll type in 9 stars, and it tells me you will need an angle of 40 degrees between 9 stars. So we were able to get a value from the user, calculate with it, and display the result in a nice user-friendly sentence that included our calculated and stored values. 2 more things. First, I promised to tell you the Python variable naming rules and conventions. Rules first. If you break the rules, then the program simply won't work. The rules are that variable names can be made up of letters, numbers, and the underscore. They can't begin with numbers, though. A variable name can't be a Python keyword. This list of keywords is from python.org, and you might recognize import as a word we've seen turn orange in a program, but nothing else. It's a good idea not to use any words that are the names of libraries or functions either, such as pygame, print, or input, as using a name that already has a meaning will probably, but not necessarily, break your program. Those are the rules. The conventions are a little different. If you don't follow a convention, but you follow the rules, your program will still run. But you will not be programming the way other Python programmers write programs, and so your programs might look really confusing to them, and you might look like a novice. The conventions actually communicate quite a lot of information. So the conventions are, most importantly, to give your variable a meaningful name. This means a name that relates the variable to the problem that you're solving, like num_stars and angle. If I had called those variables x and y, it would be a lot harder to tell what my program was calculating and why. Second is to use the underscore to separate words, as I have done with num_stars. Third, your variables should be complete words and not abbreviations unless the abbreviations are commonly used. Finally, always begin your variables with a lowercase letter. Don't begin with an uppercase letter or an underscore, as those have special meaning. Programs are read more than they're written, so it's very important to write a readable program. One way we do this is by naming variables well. Another quality of readable programs is that they don't contain magic numbers, like the 360 in our program. This value, 360, is called a literal, because it literally evaluates to what you see, 360. Consider that we don't know what num_stars or angle will evaluate to, for example, because we don't know what the user will type in at the prompt. But 360 will always be 360. Programmers refer to literal values sprinkled throughout your code as magic numbers because it isn't clear what they mean because they aren't named. We're going to name 360 as degrees circle. I will do that under my annotations. I'm adding degrees circle :int equals 360. You can see this is different from my other variable annotations because I've named the variable with all uppercase letters and I've used an assignment statement to give it a value. Why? I thought I just said to name variables with lowercase letters. The convention in many programming languages is to name constants, variables that will not change, in all caps. This communicates to other programmers that this name will always be associated with the same value. Constants should be declared near the top of the program. And now, instead of using 360 in my calculation, I'm going to use the constant name degrees circle, which makes my calculation even easier to read. To practice with these concepts, first write this program without peeking at the video or the program you just wrote if you were following along. After you have it working, try writing other programs that obtain a value from the user, perform a calculation, and display the result. For example, you could obtain a temperature and convert it from Fahrenheit to Celsius, or you could obtain a measurement and convert it from inches to centimeters, pounds to kilograms, feet to inches, pints to gallons, or any conversion you like. Once you've written a few of these input processing output programs, you're ready to move on.